Hello and welcome to the fourth video of the August 2016 Algebra 2 Common Core exam. We are going to do problems 25 through 31. Hey, it's me, it's Visca. I just did that because I saw my doctor recently, and he's a great doctor, and he's from India, and he sounds just like that. I love his accent, and I thought I would pay homage to him by doing this and saying, let's start with problem 25, okay? This is the fourth video, okay, 25 through 31. Let's do this. As always, I want to read the directions here. 25 is the start of the short answer section, okay? So answer all 8 questions in this part. Each question will receive 2 points. Clearly indicate necessary steps. Utilize the information provided for each question. There is a reference sheet, okay? So keep that in mind. Maybe there's something in the reference sheet, okay? A correct numerical answer with no work will receive only 1 point. It doesn't matter if it's a 2-point question, a 4-point question, or a 6-point question. This statement is on all of those. Okay, you would get 1 out of 2 for these, 1 out of 4, and 1 out of 6. This does not say you get half credit. 1 out of 2 is half credit. So you're not going to get 2 out of 4 and 3 out of 6. No, 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 no. You only get 1 point, no matter what the question is worth. So let's start with number 25. The volume of air in a person's lungs. Oh, good stuff. As the person breathes in and out, can be modeled by a sine graph. Okay? A scientist is studying the difference in the volume for people at rest compared to people who are told to take a deep breath. When examining the graphs, should the scientist focus on amplitude, period, or midline? And explain your choice. Okay, so I know a sine graph looks like this. It's an S. And they are talking about the volume of air in a person's lungs. So let's say this is volume. Okay, should we focus on the amplitude, the period, or the midline? Well, the midline is right here. I guess that's your starting point before the person takes a breath or not. Okay, that's where you start. That's not so much. Okay, the period is the length of one cycle, okay? If they want to study the volume, okay, they want to study the difference in volume, okay? They don't care how long one cycle is. They don't care about the x-axis. That is typically time, like how long the person has held this in. It doesn't say anything about time here, but the x-axis more than likely is time. Volume, since the sign represents volume, that's the y-axis. If they want to know the difference in volume, I want to know the difference in my y values. That means how high and how low I go. And by definition, that is amplitude. Okay? So let's answer this question. We know what the answer is. So I'm going to say, okay, the scientist should focus on what? I'm going to say amplitude. Bang. And now explain. Okay, well, by definition, and this is just me writing. I mean, you don't. I'm going to write it my way. By definition, amplitude measures the max and min values. Okay, that's why, because he wants to know the difference in volume, right? So max and min values, I can just say comma, in this case, of volume. All right? And that's what he's studying, okay? So that, I think, is an important thing to say. You don't have to say by definition. That's just me being a math nerd. Amplitude. Why? Because amplitude measures the min and max values of the volume. All right? That's perfectly stated. That's it. You really just have to know what the definition of amplitude, what amplitude represents. And now it's paid off on the final. Ka-ching. Number 26. I put this on a very easy quiz, and it's funny, the kids are going to take that quiz today. This is another explain problem. Explain how 3 raised to the 1/5, all of it squared, can be written as the equivalent radical expression the fifth root of 9. Okay, so I'm going to write each step out. I'm going to convert this into this and write a note along the way, because that's going to be my explain. So 3 to the 1/5 squared equals 3 to the 2/5. Because my rules of exponents say I got to multiply these two, don't they? 1/5 times 2 is 2/5. So then I put exponents raised to exponents need to be multiplied. Okay, now on the test, you should write these words out. Like I shorthand, I abbreviated exponent and multiplied, but you should write them out. That's the first step. Now, the second step, I would say 3 to the 2/5 equals, okay, the fifth root, yeah, that's a 5. The fifth root, let me write that nice for you guys. I was ahead of myself. I was already writing my 3, the fifth root of 3 squared. And that's because it's converting a rational exponent to radical form. Okay, now if this word rational throws you off, you can use a fraction exponent. It's the same thing. So converting a fraction exponent to radical form. I tell my kids, okay, and I've said this in some of the notes, top comes down. Okay, top comes down, and the bottom goes out. Okay, so if I have anything, let's say if I have 7 to the 3/5. Okay, the top comes down with a 7. The bottom shoots out and becomes the root. So I say top down, bottom out. Of course, you're going to say that this is the denominator on the outside and the numerator is on the inside. But the reason I'm saying this is because on the test, you should not write top down, bottom out. Okay? On the test, you should say when you're converting a rational exponent to radical form, okay, you can just say the numerator. In fact, what I wrote is fine. How are these two equal? Because this is the rule for converting a rational exponent to radical form. All right, that's the next thing I do. Now, the last thing I do is I take the fifth root of 3 squared equals the fifth root of 9. And now I'm done. I have started with this, and I've ended with this. And my last thing is I can just say because 3 squared simplifies to 9. Okay? So not only have I shown every step, oh, look at that, Amanda Robinson. Let's close that. Boom, we don't want to see that. All right, so I've showed every step, and I've explained every step. Okay, to me, that's legit. All right, I have first step is I took an exponent that was raised to an exponent, and I multiplied them. That's how I got here. Then I converted my rational exponent to radical form. That's how I got here. And then I just squared 3, and I got 9. So I got here. I mean, it's simple. It's simple. Speaking of simple, number 27 tells us to simplify xi times I minus 7i squared, where I is an imaginary unit. All right, let's expand this whole thing out and kind of see what we can do with it. This xi I'm going to leave alone. The first thing I'm going to do is FOIL this. If I have I minus 7i, okay, actually, I'm not even going to FOIL it. You could have taken I minus 7i and multiplied it times I minus 7i. But you know what? I can actually combine these. I can combine those into one term. Oh, what an easy way to do this. I have one I, and I take away 7 i's. That gives me negative 6i. So right now, that's negative 6i squared times xi. Wow, that was a million times easier. I probably did that on the answer key, and I just haven't looked at the answer key in like 2 years. But look at me. I am proud of myself. Now, I am going to square this. Okay, if I square negative 6, I get positive 36. And I squared is I squared. Times xi. Oh my God. I tell my kids all the time, you need to remember this. I squared can be replaced with -1. So I have xi times 36 times -1 because I squared becomes -1. So 36 times xi is 36xi times a -1. I just negate it. Wow, these part 2 problems really aren't, they're just not, I mean, I can understand that first one because everybody hates trig for number 25, but 26 and 27 are walks in the park. And then we get to 28 where you guys will crumble like an earthquake shaking a third world city. I don't know how I just came up with that, but that's just sad. And you'll do fine for 28 as well. Using the identity, sine squared plus cosine squared equals 1. They give that to you. Not like they're expecting you to know that. You would have to know that in pre-calc and calculus. But in Algebra 2, they give that to you. So chances are you're going to have to use that, considering it starts using the identity sine squared plus cosine squared equals 1. Find the value of tangent of theta to the nearest hundredth. You're probably going to have to put something in the calculator. If cosine of theta equals -0.7 and theta is in quadrant 2. All right, this will come into play eventually. All right, so first, the way my mind works is I'm going to put S for sine and C for cosine. Sine squared plus cosine squared equals 1. Okay, I know what cosine is. Cosine is -0.7. So I'm going to just substitute that in for my C. So sine squared plus -0.7, that's for cosine. I still got to square it, equals 1. Now, keep in mind, ultimately, they're asking me to find tangent. Okay, tangent, okay, is equal to sine over cosine. S over C. So I have cosine, right? -0.7. I just need to find sine. And that's what this is going to help me do right here. Okay? So, here we go. So I've got sine squared plus, if I square this, I get 0.49 equals, excuse me, 1. Let's solve for S like it's just a normal variable, shall we? I am going to subtract 0.49 from both sides, and I get sine squared equals 0.51. Okay, if I subtract those, I get 0.51. I need sine. Okay, they want me to find sine, not sine squared, so let's get the S alone. Sine equals radical 0.51. Yeah, I can get a number, but then it's going to be some run-on decimal, so just leave it. Okay, -0.51. Now, I said this would come into play here. Okay, quadrant 2. Some of you might say, like, well, Visca, isn't that plus or minus? Because if I square them, I'll still get a positive. Yeah, but in quadrant 2, okay, here's quadrant 2. All students take, so tempting, but I'll say calculus. Take cookies. All students take cookies. Okay, what these letters represent are which trig functions are positive. All three, sine, cosine, and tangent, are all positive here. Okay, sine is the only positive in quadrant 2. Cosine and tangent are both negative. Okay, so when I look at this, yeah, it's plus or minus if I were evaluating this mathematically. But since we're in quadrant 2, my sine should be positive, so I don't want the negative. Okay, so sine is my positive version of 0.51. All right, so let's take that. Let's take that up here. All right, sine is now radical 0.51. All right, good, good. So I've got radical 0.51 over -0.7. I've got to do this. I've got to use the calculator. All right, I've got to use the calculator. So let's take this. Oh, this was another problem. Clear this. We'll say radical 0.51 divided by, yeah, I don't want to be in the radical there. Pop out, then divide by -0.7. And I get something that's, okay, cool, cool. Tangent of theta equals negative 1.0202. They want to the 100th, so I'll say negative 1.02. That is tangent. Now, if I wanted to check, this is in quadrant 2, right? Isn't tangent negative in quadrant 2? It is. So my tangent should be negative. Not too bad. I mean, that was really, I mean, it looks like a lot of writing, and I was explaining this as I went, but really, I just used, I mean, this is almost like the Pythagorean theorem. A squared plus B squared equals C squared, kind of. So you really just used a trigonometry version of that to solve for a variable, and then I created a fraction with it. That's really all you did, okay? You know, I like problem number 29. I don't like the 2 paragraphs, but I like the math behind it, and if you just read the problem, it's not too bad at all. So number 29 says, Elizabeth waited for 6 minutes at the drive-thru at her favorite fast food restaurant the last time she visited. She was upset about having to wait that long and notified the manager because, hey, who needs to wait that long for a Baconator? Am I right? Am I right? The manager, just like any fast food manager, came out and assured her that her experience was very unusual and it would not happen again, ma'am. In fact, here's another Baconator. Have fun. All right? So the second paragraph goes on and says, a study of customers commissioned by this restaurant found an approximately normal distribution of results. Ah, I love seeing those words. Oh, man, that is way off. Normal distribution. Okay, let's get rid of this one. So I know when it says normal distribution, standard bell curve, all my rules apply with standard deviation and whatnot. Okay? The mean wait time was 226. Wow, this is, let's do that again. The mean time was 226 seconds, and the standard deviation was 38 seconds, okay? Given these data, and using a 95% level of confidence, that is the moneymaker, 95%, okay? Was Elizabeth's wait time unusual? Okay. Love. No, I don't want a crayon. I want this thing here. 95% confidence. Was it unusual? Nah. Okay, so 95% should immediately have you think it is the mean plus or minus 2 standard deviations, okay? Inside this interval is everything that is normal or everything that is considered usual, all right? If Elizabeth's wait time is inside this interval, it's normal. If Elizabeth's wait time is outside this interval, it is not normal, therefore it is unusual, okay? So we just need to figure out what this interval is. Well, they give us, let's get some more highlighters. The mean is 226 seconds. So the mean is 226 seconds, plus and minus 2 times the standard deviation. This time we'll go blue, and the standard deviation is 38 seconds. So, okay, I need to put this in the calculator. All right? I mean, I don't have to, but, you know, let's be realistic. You're going to have a calculator, you're going to use this, and you want to check your math on. There we go, finally. So we've got 226 plus 2 times 38. Okay, there is no plus or minus button in the calculator. Don't try and find it. We've got to add the 2 standard deviations, and then we're going to subtract them. Boom. 302 is my high point. So if I take 226 and subtract 2 of my standard deviation, which is 38, that's 150. Bang. So what I know for a fact right now is from 150 seconds to 302 seconds, this is my moneymaker. Okay, these are considered normal wait times. They are considered usual because this problem uses the word unusual. These are normal. These are usual. Anything outside of this is considered unusual. Now, Elizabeth, my friend who loves baconators, okay, let's go pink for Elizabeth here. Elizabeth waited 6 minutes. Aha! They gave us seconds, okay? They gave us seconds. We need minutes, okay? Or we can say if Elizabeth waited, okay, Elizabeth waited 6 minutes. Well, there's 60 seconds in a minute, so if I times that by 60, that's 360 seconds was Elizabeth's wait time. Is that inside this interval? No, it is not inside this interval. So this is unusual. Yep, usual. Did I spell that un? Oh, I spelled usual here. I'm going to check my spelling. Usual. Okay, yeah, no, I did it. I just had to add the extra U here, 3. Weird. Unusual is weird. Anyways, let's get back to math. So, here we go. We need to answer this question. Was Elizabeth's wait time unusual? Well, yes, it was. It was not in our interval. So let's answer that. Yes. Lizzie, no, you should use Elizabeth. Use everything they give you. Yes, Elizabeth's wait was unusual. And you know, it says justify. I mean, I think the math work justifies it. But in a problem like this, I'm just going to finish explaining this. 360 seconds is not in the normal wait time. Sorry, I'm writing sideways. Of 150 to 302 seconds. Okay. So yes, that is definitely unusual. Okay, she waited 360 seconds. She waited, oh my God. I mean, the maximum time to wait on average is 302. She waited at 360. That's almost a minute. I mean, she waited an extra 58 seconds. She was so pissed. That Baconator might have been cold by then. That's sarcasm, people. If you have to wait an extra 60 seconds, just be okay. But now you can do the math behind it. Cheerio. Number 30. The x value of which function's x-intercept is larger, f or h? Justify your answer. Okay, so first of all, do you know what an x-intercept is? That is when your y equals 0. What do I mean? If I have an axis here, an x-intercept is something that touches the x-axis. Let's say right here. This is at number, let's say this is at 3. Let's put another one here at -1 and put another one here at -5. Okay, let's say we got 3 dots here. And I do the following. Okay, if I want to know the coordinates of each of those, this is at 3, 0. The middle one would be at -1, 0. This one on the left would be -5, 0. These are x-intercepts because in order to be on the x-axis, the y value has to be 0. Let's first establish that. All right. So which x-intercept is larger? I need to find the x-intercept for both my h function, badush, and my f function, katash. Okay. The h function is the easiest. Now, please keep in mind, if this is my x, h of x is the same thing as y. Y is 0, because remember, we want when y is 0, right? When x is 2. So my x-intercept for my h function is 2. That was simple. This, I mean, it's simple as well. It's just not as simple as reading a table, or it could be. But anyways, I digress. This is the same thing as y equals log of x minus 4, okay? My x-intercept is when y is 0. All right? So I can do two things. I can graph this in the calculator and physically look to see where it touches the x-axis. Axis, where it touches the x-axis. Let's do that. Or I can look at the table and I can try and identify where my y is 0 as well on that table. So the first thing I'm going to do is I'm going to grab the calculator. There it is. And I'm going to look to put in, turn it on. Are you counting how many times I'm hitting this on button? There we go. Clear. I'm going to go to y equals, which is right there. I'm going to clear this poop. Oh, that was from last test. Oh, look at me go. And I'm going to put in log, which is right here next to the number 7 button. I'm going to put x minus 4, just as it's written. X minus 4. Bang. And I am going to graph this. Let's make sure the window, if we go to zoom, I want to make standard, which is 6 here. Okay, see that? So 6. That will bring me back to a 10 by 10 window. Oh, okay, look. Look, this might be easier than I think. It crosses somewhere around right here. And because I'm a freak with zooming, I'm going to hit zoom box, which is 1. And I'm going to zoom in. Enter. And it turns into this little box itself. And now I can start drawing my box. And I only care where it crosses the x-axis, okay, right here. And I hit enter. Bam. Now we kind of get a clear look right there. I'm going to look at my table. And I'm going to see where the x-intercept is. Maybe it's going to be something clean like this, where y is 0. So if I look at my table, that's the graph. I should hit second graph. And if I scroll up, oh, look at that. At 5. So my x-intercept, okay, is when y is 0. Remember, our y has to be 0, right? Here's where y is 0. It's at x is 2. Y is 0 is when x is 5. That was real easy. Man. So my x-intercept is at 5. Okay, now we didn't answer the problem yet. Let's just get this out of the way. Bam. We didn't answer the problem yet, okay? Because it says which function's x-intercept is larger, f or h. You need to answer. F has a larger x-intercept. Bam, and it's 5. Oh, goodness gracious, these problems. In basketball, we like to say it's a layup, children, because it's easy. It is an uncontested layup. It's not like LeBron James is going to swat that ball in your face. And no one in it. You got like a fast break. Everybody's like 6 feet behind you. You got it. 31. The distance needed to stop a car after applying the brakes varies directly with the square of the car's speed. The table below shows stopping distances for various speeds. All right, here we go. If you're going this speed, you need this distance in order to stop. So if I'm going 10 miles an hour and I start to hit the brakes, I need 6 1/4 feet before I come to a complete stop. If I am traveling 40 miles an hour and I start to hit the brakes, I need 100 feet before I can come to a complete stop, okay? That's what this table is telling me. So, determine the average rate of change. Oh, that should tell you right there everything you need to know, but let's continue to read. Determine the average rate of change in braking distance in feet per miles per hour between one car traveling 50 miles an hour and one car traveling 70 miles an hour. Now, I scoffed. I scoffed when I said the average rate of change. If you don't know this by now, rate of change means slope, okay, from 50 to 70 miles an hour. 50 to 70 miles an hour. I have one coordinate, and here's another coordinate. These are my x's, these are my y's, all right? Slope is change in y over change in x, all right? So let's call this y2 and x2. Let's call this y1 and x1, because you know this is y2 minus y1 over x2 minus x1. God, this is an Algebra 1 problem. Do I have the August 2018 Algebra 1 exam? Man, this is nuts. Man, I hope you guys get easy problems like this. Probably not, but let's go. Let's do this anyways. Okay, so y2, which is 306.25 minus y1, 156.25, all over x2, 70 minus x1, 50. I'm going to put this in the calculator just like that. Okay? No, here we go. I'm going to put that fraction just like that. And you guys know I love me some alpha y equals enter, because that puts a fraction in there for me. I'm literally going to type what I have, 306.25 minus 156.25. Put that all over 70 minus 50. Hit enter, and it's 7.4975. Okay? So that is 7.4975. Okay? That's a weird number to get. Let me check my calculator again. Oh, calculator. If you notice, maybe you noticed this in the video, the 5. I can't. See right here, it says 0.2. I swore I pressed the 5. This would be 0.25 like it is right there. So let me just change that. Will that change our answer? Maybe ever so slightly. But it's still, if it changes our answer, you always got to second insert a 5. Okay, 7.5. I would have rounded that to 7.5 anyways. Yeah, that's me covering my tracks. 7.5. So how come all of my y numbers, decimals, are 2 decimal places? So I would have made this 2 decimal places, which would have rounded to 50 anyways. But really, you should type it in the calculator in the right manner. So this is the rate in feet per miles per hour. So if I am going to adjust that, I will call that 7.5 feet per miles per hour. Done. All right. And last but not least, they come to this problem here. Explain what this rate of change means as it relates to braking distance. Okay. So again, I'm doing this between 50 and 70. So I'm going to state that from 50 to 70 miles per hour, for every extra mile per hour you go, you need, I don't know why I keep on forgetting the U's there, you need 7.5 extra feet to stop. Bam. Okay? So let's think about this. 7.5 feet per miles per hour. This is braking distance. This is the distance you need to come to a complete stop. So for every 1 mile per hour faster you go, okay, so you're changing. This is a rate of change. So for every 1 mile per hour faster you go, you are going to need an additional 7.5 extra feet to stop. All right? That's the explanation of it. We are done. My doctor would be proud. I'm so very proud. You guys did such good work. 110%, even though, you know, you can only max out at 100%. All right? So, fantastic. 34 minutes. Look at us go. Booyah. And I will see you for video 5, where we will finish off this exam and do problems 32 through 37. I hope to see you then. Keep studying hard, because you are going to ace this test.